So this is part 2, and as much as I'd like to do every even problem or as many problems as I possibly can, it's just going to get too long, the video, and these aren't that bad. I don't think you need to see every single example, so I'm going to really skip around quite a bit. There is one new thing to learn. It's when the problems aren't set equal to 0, what to do. So let's do 9. In number 9, the A is going to be 3. The B is going to be -4. And the C is going to be 3. I'm going to write Z equals just because the variable is Z. But if you wrote X because you didn't notice, not such a big deal. I'm probably going to do that, before today's over. Then in the numerator, negative sign from the formula, and then B is negative, so that B should go into parentheses. Under the square root symbol, B squared, which is -4 squared, minus 4 times 3 times 3, all over 2A, which is 2 times 3. I always make any double negatives positive on my kind of first bit of algebra, simplify the denominator, and get the square root down to a single number. So -4 squared minus 4 times 3 times 3. Under the square root I should get a -20, which means I'm going to get an I, which means my answer should be written as separate fractions. It would be illegal right now. This cannot reduce. Those you can't reduce. If you did that, you're going to get an answer that's not right. I'm going to make 2 separate fractions in a minute here, and then I will reduce those, but the way it's written now, I can't. When it's in one fraction, you can. When it's in this compound fraction, you can't reduce. For the square root of 20, I made the square root of -20. I introduced the I and made the 20 positive. And the prime factoring for 20 gives me a 2 in front of the radical because the prime factoring for 20 has a pair of 2's. And it gives me a 5 under the radical. I could definitely reduce everything by 2 right now. That would be completely legal to do. I'm looking at my key and it's saying I have a mistake. I wonder, let me just make sure that I'm not writing something down wrong and that my key is actually wrong. So under the radical is where I think I might have a mistake. So I'm going to go -4, which is B, squared minus 4, parentheses 3 for the A, parentheses 3 for the C. Yeah, I just have a mistake on my key. I'll make a little note to myself. This is legal reduction because all 3 numbers are in the proper place. One to the left of the plus or minus sign, one to the right of the plus or minus sign in front of the square root. That's not the best answer. If I entered this on my calculator when I'm in mode 2, if I entered the fraction 4 plus 2 square root of 5, make sure the i's outside the square root, not under the square root, over 6, my calculator is going to default into 2 parentheses, or 2 fractions. And so I'm going to make those 2 fractions up. First fraction is going to be 2/3. And then after the plus or minus sign, I get the square root of 5 over 3. And instead of taking the time to write it in the numerator of the I and then move it over, I'm just going to move it over. If my answer has a plus, it has a square root, or it has an I should leave the plus or minus in my answer. There's a way to get my calculator to do these, but I don't want to show you that because then you'll just press buttons and That's not good, but I just press buttons to make sure of my answer. Okay, I need to skip some more because we're already 5 minutes into this video, and let's do number 11 together just to knock out some of your homework. So in number 11, the A is going to equal to 9. The B is going to equal to negative 12. The C is going to equal to 2. And I need to know that the formula is negative B plus or minus the square root B squared minus 4AC all over 2A. I actually haven't written the test yet, but I plan to put the formula on the test. I'm going to write y equals fraction, negative sign from the formula, and then negative 12 for my B, and then plus or minus under the radical B squared is going to be in a parentheses negative 12 squared, and then minus 4 times A, which is 9, times C, which is 2, all over 2 times 9. By hand, I made the double negative in the numerator positive. By hand, I multiplied the 2 and the 9 in the denominator. By calculator, I'm figuring out what single number the square root reduces to. And then I'm going to reduce the square root of 72. Just to save a minute, I'm going to reduce it on my calculator rather than using the prime factor tree, even though I want you to use the prime factor tree, or show me how you do it in your head if you can do it in your head. But just to save a minute, and that's a skill that we already know, I'm reduced the square root on my calculator. And now I look at this. My answer should have a plus or minus because the square root that's left in the numerator. And all three numbers I circled here are divisible by 6. So I'm going to go 12 divided by 6 is 2. 6 divided by 6 is 1. 18 divided by 6 is 3. And for my answer, I'm going to write y equals, in the numerator, I get 2 plus or minus the square root of 2 over 3, listed as one fraction. If you don't have an I, you don't get the two fractions. I'll show you this on my calculator. I'll do fraction 12 plus square root of 72 over 18. And my calculator says that's the way I want to see it. One fraction when you don't have a square root. One fraction when you don't have an I. Multiple fractions when you have a square root. So let's maybe try to get like 5 or 6, maybe 5 more problems done from the bottom section. And in the bottom section, the problems aren't set equal to 0. Some of them even have factoring. The quadratic formula, if you jump right into using the quadratic formula and the problem isn't set equal to 0, you won't get the right answer. The formula very specifically needs the problem to be set equal to 0. And for algebra of ease, I like to have the A term positive. So my formula says set it equal to 0, keep the A term positive, because getting a negative in the denominator is not fun. So if I was doing problem 14, before I could jump in and do the quadratic formula properly, it has to be set equal to 0. If it's not set equal to 0, then you're going to be having some of the signs on the variables wrong. And one sign error will make the whole answer completely different and wrong. So at 14, I set this equal to 0. And now I'm going to go A equal to 1, B equal to 9, C equal to negative 10. Now I'm going to write X equals negative sign, and then the B, which doesn't need to be in a parentheses because it's positive. Under the radical, just to be safe, I'm going to put my B's in the parentheses every time, even though they don't always, even though it really only needs to be in a parentheses when the B is negative. So I put my numbers into the formula. No double negatives to worry about to the left of the plus or minus sign. but the denominator I can divide by 2. Get the number under the radical down to a single number. And that's such a nice square root. Because the square root's going to completely go away, I should make up one problem with the plus, one with the minus, and get separate answers. I shouldn't have a plus or minus in my answer. So if the square root goes away and you don't have an I, you should make up separate problems. One problem with the plus, another problem with the minus. Negative 9 plus 11 over 2, those have opposite signs. I'll subtract and get positive 2 over 2, which is 1. The next one, negative 9 minus 11 over 2, those have the same signs, so I'll add them and keep them negative, and then reduce. I believe I get x equal to 1 and negative 10 for number 14, and that's what I have. Let's do 15. It looks ugly. 14 minutes and I want to stop, so we're not going to get as far as I want, but we'll get far enough, I hope. So same problem with 15. It's not set equal to 0. If you jumped into using the quadratic formula before setting the problem equal to 0, you'll get an answer that could look drastically different from the right answer. So my A is going to be 2. My B is going to be positive 5. My C is going to be negative 8. And I'll go T equals negative sign and then B, which is 5. No parentheses needed there. Plus or minus B squared, which is 5 squared. I always put that in a parentheses for safety. And then 4 times A times C all over 2A. In the numerator, the negative 5 can stay a negative 5. In the denominator, the 2 times 2 can become 4. And then under the radical, 5 squared minus 4 times 2 times negative 8 gives me 89. I think 89 is a prime number. Let me try to do a prime factor tree for 89. Actually put it in degrees, minutes, seconds. 89 is prime, so that radical doesn't reduce. That's the best situation. I love it when the radicals don't reduce because it means there's nothing I can do. The radical doesn't reduce. I should leave a big fraction because I don't have an I. And the only way this could reduce with the 4 is if there was a number outside the square root and before the plus or minus sign that the 4 divided evenly into. So that's just my answer. I'm going to jump all the way down to number 20 and get it set equal to 0. I hate the A's being negative. So if I'm doing number 20, I don't mind having the 0 on the left-hand side, and that's what's going to happen when I do my math, because I really, really, really don't do well with a negative A, because it puts a negative in the denominator, and I think it makes everything harder. So I'm going to add 5y and add 6y squared to both sides. On the left side, I just lined everything up. The 5y's on top of each other, the 6y squareds on top of each other. On the right side, I need to write them in standard form. So I'm going to write the 6y squared first, the plus 5y second, and then a plus 4. And now my A is 6, my B is 5, and my C is 4. I'm not writing the quadratic formula down, but you should have it at your fingertips. I'll give it to you on the test. So I get negative B, which is negative 5, plus or minus b squared, which is 5 squared, minus 4 times 6 times 4 all over 2 times 6. If that 6 in the denominator was negative, I'd make so many mistakes anyways, way more if the denominator has a negative. So when I'm rewriting it, I will force the a to be positive by getting the square term on the side of the radical, on the side of the equal sign that makes it be positive. Under the radical, I get negative 71, which means I'm going to get an I. And when I get an I should write two fractions as opposed to leaving it as one. And now I'm going to make this into the two fractions because the 71, it's a prime number. The radical doesn't reduce. So the two fraction form of this is going to be negative 5/12 plus or minus the square root of 71 over 12. And I'm going to drag the I off to the right. Couple more. Let's do 21 of yours. 21 has a parentheses, which is absolutely not helpful whatsoever. Most of the rest of the problems have parentheses. That's the last thing you need for the quadratic formula. The quadratic formula needs 3 individual terms, and it needs to be set equal to 0. This is way far away from being able to use the quadratic formula. If there's parentheses and I want to use the quadratic formula, I need to get rid of the parentheses. And so I'm going to do the foiling on the left-hand side. Do x times x and get x squared. Do x times minus 3 and get minus 3x. Do 1 times x and get plus 1x. Do 1 times minus 3 and get minus 3. Closer to be able to use the quadratic formula, but still not there. I need 3 terms. I need to have it set equal to 0, which I don't have yet. I'm going to combine the minus 3x and positive 1x to get a negative 2x. Even closer yet to be ready for the quadratic formula, but the quadratic formula needs it equal to 0. So I need to do a boatload of algebra if I want to use the quadratic formula, because the quadratic formula is very particular. It wants exactly that form, a trinomial with a second degree term, a first degree term, and then a constant equal to 0. So for now, I'm going to plug off my numbers. My a is going to be 1. My b is going to be negative 2. My c is going to be negative 15. And I'm going to get x equals negative, and then b in a parentheses because it's negative. That's the negative b part. Plus or minus negative 2 squared. That really does need a parentheses. Minus 4 times 1 times negative 15 all over 2 times 1. That's just pushing the numbers through the formula. Double negative in the numerator, I'm going to make a positive. 2 times 1 in the denominator, I'm going to make a 2. And then under my radical, inside of parentheses, negative 2 squared minus 4 times 1 times negative 15. The underside of the radical comes to 64. That's a square root that I know, so I'm going to reduce that square root. I'm going to make this 2 plus or minus 8 over 2, because the square root of 64 is 8. I shouldn't have a plus or minus in my answer because there's no I left and there's no square root left. I'm going to reduce before I split the two problems up because I can. I'm going to go 2 divided by 2 is 1. 8 divided by 2 is 4. 2 divided by 2 is 1. I've canceled the denominator down to 1, so I don't need to write a fraction. That's what I'm going to split up into my two problems to get my answer. So I'm going to split this up into x equals 1 plus 4 and x equals 1 minus 4. The 1 plus 4 is going to give me a 5. The 1 minus 4 is going to give me a negative 3. And when I go to write an answer down for 21, I'm going to write x equal negative 3 and 5, or x equal 5 and negative 3. So one more problem, and there's a bunch of them coming up with parentheses. This is just the next one in the line. I almost think maybe 25 is better. It looks a little more complicated. So let's do 25 instead of 23, 24, and we'll call that the end of the video. So in 25, that parentheses is absolutely worthless. I'm going to clear the parentheses and do 3x times x and 3x times 1. The 3x times x is 3x squared. The 3x times 1 is plus 3x. I still have the minus 6x. I still have the equal to 9. Closer, but not enough for the quadratic formula because I have not equal to 0 and I've got too many x to the first power terms. The x to the first power terms will combine to be minus 3x because 3 minus 6 is minus 3. And then I'm going to minus 9 minus 9. After I do all that algebra, the problem is ready for the quadratic formula. We have three terms that set equal to 0. The a is going to be 3. The b is going to be negative 3. And the c is going to be negative 9, assuming I don't have any mistakes. So x equals to big fraction negative, b goes in a parentheses here, negative 3, under the radical b in a parentheses squared, negative 3 squared, minus 4 times a, which is 3, times c, which is negative 9, all over 2 times a. Double negative in the numerator, I make a positive. 2 times 3 in the denominator, I make a 6. And then I get the underside of the radical down to a single number. So negative 3 squared minus 4 times 3 times negative 9 gives me a 117 under the radical. Ooh, maybe that factors. Let me make sure I'm in mode 1. 117, shift quotes. Oh wow, 117 is 3 times 3 times 9. I had no idea. So 117, it's prime factoring. It's 3 times 3 times 13, should I say. The square root of 117 is a reducible square root. Specifically, I could get a 3 in front of my radical and a 13 under my radical. Since the radical doesn't disappear, I should have a plus or minus sign in my answer. Since I don't have an I should have one fraction as opposed to two fractions. All three numbers I circled are divisible by 3, so I'm going to divide them all. The number before the plus or minus sign I can't suppress. I need to write a 1 there. But the 1 in front of the square root isn't necessary. And then the denominator is 2. I'd say that's probably the best answer for number 25, and that's the answer I have written. So we're at 24 minutes. That seems good enough. Just try to finish up the odds I haven't finished yet. And we just have 2 more sections left. Next section is a graphing section. It's long, like so many of the sections this semester, but it should be easy. Absolutely want to have your calculator ready. And, maybe some graph paper will make it quicker for you to graph, I would think, but you don't need graph paper to do graphs in the section that's coming up.